Hey class, this is the AP Chemistry problems for Chapter 16, the ICE problem, so let's get right to it. Here we have the Ka expression written out for us, 3.2 times 10 to the negative 8th as the Ka. Notice that I have, so I'm going to do one thing first. I'm going to go through, write the chemical equation. I'm going to do letter A first, so letter A comes, there we go, comes up here. Notice that, of course, we have this stuff. We have products over reactants. So there's our products. There's our reactant. I'm going to make sure, though, that when I do this, when I write the HOCl, I'm going to definitely add it to water. That way, I can produce this part right here, the H3O, the hydronium ion, like this, and the OCl minus. Okay, so this all works just like that. There's no... what's really nice about most of these problems is that they're all monoprotic, which means that there's only one hydrogen, which means that we only have to worry about, like, there's no balancing here because they're all balanced already. So that does take away some of the, so everything's a 1-to-1 mole ratio, which is helpful as far as some of the stuff we're going to do later on. Okay, so we wrote the chemical equation. Calculate the pH. Now you should be able to write the chemical equation, or vice versa. If you're given the chemical equation, you should be able to write the K expression for that chemical equation. You guys know that you would not include water because it's a liquid, but everything else that's AQ or a gas should be included. Okay, so if I do this, then it should be obvious that for the K expression, I would not include the water, but I would include the rest of it. This, of course, would go on the bottom because that's a reactant, and then our two products would go, of course, on the top. Okay, so let's get back to, you should be able to calculate the pH. When it asks for the pH, that means that you are looking to find the concentration of the hydronium ion first. If you don't like the hydronium ion, for whatever reason, because you're not used to seeing it, then you can just consider that you're looking for the H+, which is these two. As far as our concerns, they are the same. They're one and the same thing. So when we look for the pH, I'm looking for either this or I'm looking for that. Either one is fine, but it does take some calculations. One of the things I might do first, since I have this, the equation for A, just, why does that thing not go away? Okay, I can move that. Okay, so I'm just going to go through and I'm going to write the net ionic equation for the reaction so I can continue on with calculating the pH further down. So write the net ionic equation for the reaction between HOCl plus, and then it's going to be NaOH. I'm going to consider the OH minus as my part here. I'm going to make water on this side, like that, and over here is going to be the OCl minus. So that is my net ionic equation. I'm doing that. Notice that I left the Na out because the Na is a plus on both sides, so that means that we can ignore that. That's a spectator ion. The Na plus is a spectator ion. That's why I went to, so A, B, and C. Now let's get to B. So you know that B is going to be, of course, oh boy, lots of stuff there. So let's do B on the next side here. There we go. So this is letter B. Okay. I'm starting with 0.175 concentration, 0 and 0 on that side. We're not even considering the H2O, of course. So, of course, for our change, we're going to have a minus X. This is going to be a plus X and a plus X. This is nothing new. This is all the same stuff that we've done before. 0.175 minus X like this, and then, of course, X and X. And when I plug this into the Ka, what I get then are these two over here as x times x, which is x squared, and 0.175 minus x, but you know what I'm going to do with that. One of the nice parts about Chapter 16 is that I get to get rid of the minus x part, and that makes everything so much easier. So this is, what was this, 3.2 times 10 to the negative 8th, I believe, for our Ka. Maybe I should check that just to make sure I don't screw this up. Okay, that's what it says on the paper. So now I'm just going to multiply the 0.75 times the 3.2 times 10 to the negative 7th. What I get when I do that is, I need to scroll down here, give myself a little bit more room. Is x squared equals 5.6 times 10 to the negative 9th, like that. I take the square root of both of these, so I get my x is equal to 7.5 times 10 to the negative 5th, which means my pH then is equal to the negative log of that number, 7.5 times 10 to the negative 5th, like that. So the pH then equals here 4.13. And you should be able to do all of that by now. This pH right here is the new, like that's the brand new chapter 16 thing, along with, when we do the Ka part here, as far as this is concerned, getting rid of the minus x on the bottom, that is the new chapter 16 thing. So if you can do that and you can do this, then you can do all the work that I'm asking you to do in chapter 16. That's it. So far, there are more things in chapter 16, but this is what I want you to be able to do. All right, I tell you what, let's stop there and we'll pick up with then D is like a new experiment. So we'll continue on to D in the next screencast.